Okay, so let's start with 8.3 day 2. We're going to actually start graphing these crazy functions that we've been finding all the pieces for. So we're going to do exactly like we were doing in day 1, just finding each piece. So for this one, let's first start by factoring. So that's going to be x plus 2 times x minus 2 on top. And on the bottom, that's going to be 3 times x minus 2. So let's just go through all the things that happen. So x minus 2 cancels. And if you remember from the last lesson, that means there is a hole. And that hole is the x coordinate. So you set x minus 2 equal to 0, which would be positive 2. And then you take that positive 2, what your answer is, and plug it back into the remaining problem. So that would be 4 plus 2, or sorry, I'm getting ahead of myself. 2 plus 2 over 3. So that would cause that number to be 4/3. All right, now let's talk about the vertical asymptote. That's the restriction that did not cancel. The only thing that didn't cancel is 3, and that's not a restriction because there's no x, so there would be no vertical asymptote. X-intercept is when you set the numerator equal to 0 after stuff canceled. So that would be -2, 0. Y-intercept is you plug in 0 at the beginning. So 0 would cause this to be 0 and this to be 0. So it would be -4 over -6, which would be positive 2/3. So 0 2/3. And your horizontal asymptote would be none because the top is bigger. Okay, and if that was too fast, that section right there, you might want to go back and rewatch day 1 because that's all of the stuff that I'm expecting that you know over day 1. That's why I didn't spend a whole lot of time on it. Okay, so now let's graph all of this, or as much as we can. So we have a hole at 2 4/3. Okay, so that would be about right there. And when you're drawing it, make sure like on your quiz and your test that I know that it's obviously a hole, like it's an open dot. It's not like a kind of in between thing. It's for sure. And then you have your x-intercept is at -2 0. Y-intercept is at 0 2/3. Now this looks like it may be a line to me, but let's make sure. So on all of these, you need to pick a few points and you're going to make a little table and plot the points. So I'd like to pick let's pick some to the right of that hole at 2. So I'll pick, how about 4 and 6? I think that should take care of the right half. And then let's also pick -8. Just something over on the left side. Just the more points you pick, the better your graph is going to look and the more likely you're going to be accurate. Because if you pick a few amount of points and you mess up on 1 or 2, then you don't even know. But if you pick more points, you're able to see if you did make a mistake on 1. So what you will do is you're going to plug in those numbers to x in the original equation. Okay, and so on these videos, I'm going to speed this up and just give you what the answers are, but I highly, highly, highly recommend typing them in your calculator. I just graded a bunch of quizzes on this, and the people who have been copying the answer key did not do well because they didn't know how to plug in the points. There is an art to the calculator. So 4 is going to give you the 0.2. 6 is going to be 8/3, or you might be at 2.7 if you're rounding. -2. And you know I'm usually a stickler about rounding, but it really doesn't matter on this because we're plotting this points and it's kind of an estimate anyway, so it doesn't have to be exactly like 2.67 or 2.6 repeating because it's a graph. We're sketching it. It's not going to be perfect. Okay, so 4 2 is right there. 6 2.7. And then -8, -2. All right, just like I suspected, this is a line. Okay, so it goes something like that. Okay, on this one, I actually knew at the beginning, before I even picked my points, that it was going to be a line. And this doesn't happen every time, but it does happen occasionally. And the reason is, let's look at this part. The stuff that canceled, that's when after the stuff canceled, that's what you were left. So you were left with x plus 2, sorry, let me get it right, x plus 2 over 3, right? So y equals. That is actually the equation of the line. If you write it in slope-intercept form, that would be y equals x over 3 would be 1/3 x, and then 2 divided by 3 would be positive 2/3, right? So look at this graph. It should match that line. Did we start at 2/3? Yes, we did. That was our y-intercept, remember? So the y-intercept is 2/3, then we went up 1 over 3, right there. Up 1 over 3, that looks like my line. You do the reverse. Down 1 over 3, down 1, left 3. That is the equation of the line. So really, I didn't need to type in all of, or write out all of these on this problem, but it's good practice just in case. But if you have one like that on the homework, you don't have to, as long as it is actually a line. And that doesn't come up all the time. Okay, so let's talk about this one. X plus 4 over x minus 4. So let's do all of the things again. So there is not a hole, right? Because nothing cancels. The vertical asymptote would be x equals 4, the restriction that didn't cancel, so 4. Your x-intercept would be at, you set the numerator equal to 0 and solve, so it would be -4, 0. Your y-intercept would be at 0, -1. And your horizontal asymptote, that is when they are the same, they're the same degree, so it's their coefficients. So we're going to write y equals 1. All right, so now let's graph all of that. So I had a vertical asymptote at 4. So looks something like that. And I like to do dashed lines on mine, so it kind of differentiates from what you are doing. And then the horizontal asymptote was at 1. Your y-intercept is at 0, -1. And x-intercept at -4, 0. Okay. So now we need to pick some points. So here's the thing. When you're picking these points, they do not have to be exactly like mine. You can pick as whatever you want. So if you notice, we have two different regions left and right on this. We have this side, which is the left side, and this side, which is the right side. Okay? When doing this, if I'm talking about the left side, I try to get as close to the vertical asymptote as I can, just to kind of give me an idea what's going to happen near that. And then I'll probably pick something over here. Okay, so let's pick, we'll start over here. Let's pick -6. And then we already have 2 points there in the middle. So then let's go ahead and pick +3, because that gets me really close to that vertical asymptote. Okay, now let's go over on the right side of the graph. Oh, I wish I could erase that. Sorry, I gotta redo that. I don't like that green. I shouldn't have done that. Okay, that's not gonna be perfect. I'm sorry, that's really ugly, but just make it work. Okay, and so now go on the right side of that vertical asymptote. The closest point the whole number point I can pick is 5. Right? And then I'm going to pick you want at least 3 points on each section of your graph. So I'm going to pick 2 more, and let's pick 8 and 10. Okay, again, I'm going to speed this up, but I would highly recommend typing this in the calculator. So for 6, you get 0.2, 3 is -7, 5 is 9, 8 is 3, and 10 is 2 1/3. So let's graph all of that. So -6, 0.2, 3, -7, 5, 9, 8, 3, and 10, 2, and 1/3. Right? Something like that. Okay. So this graph has two sections like we said. It's going to get close to those asymptotes, but it's not going to actually hit it. And it is going to curve that way for that half. And this half looks like it's going to do something like this. Okay, it's not perfect, but it's the best I can do right now. So there is your graph. Ignore the green. There is your graph. Notice these are smooth curves. I'm not using Notability, so it's kind of a little jagged. But these should be very nice and smooth curves. Sometimes on quizzes, I'll see, or tests, I'll see like just like that. Something like that. That's not good enough because that looks like it runs into that vertical asymptote and you don't want to do that. Also, sometimes it never fails. I'll see something like that. Don't do that either because obviously all these curves are going to be smooth. You don't want to have anything that's jagged. All right, let's do the next one. C, x times x plus 1 over x plus 1. So if you notice, the x plus 1's cancel. That tells you that there is a whole. So the whole would be at -1. And then we need to plug -1 in for x on what's left. So that would be -1. Since there's nothing on the denominator, that's just 1. So that would be -1. Okay. Vertical asymptote would be none. X-intercept is you set the top equal to 0 after stuff cancels. So all you have left up there is an x. So that would be a 0. So x-intercept's at 0, 0. Y-intercept is at 0, 0 as well. Horizontal asymptote, the degree of the top, if you multiplied it out at the beginning, it would be x squared plus x over x plus 1. Since the top is bigger, there is not a horizontal asymptote, so none. Oh, I'm sorry, I skipped the y-intercept, my bad. So y-intercept is when you plug in 0 at the beginning, so 0 times 0 plus 1 over 0 plus 1. So on top, that would be 0 times 1, so 0 over 1. 0 over 1 is 0. That's a lot. I'm saying 0 a lot. I'm sorry. So the y-intercept is 0, 0. Okay, so now let's graph all of this. Actually, I'm going to pause. Did you notice that the stuff after the stuff canceled, we just have the equation y equals x? What is that? Well, that's an equation of a line, right? Y equals x. The slope is 1. The y-intercept is 0, which is matching up to what we have. So we have a y-intercept at 0, 0. Don't forget about that whole at -1, -1. And then the slope is +1, so up 1 over 1. So sure enough, this is a line. If you wanted to make a table and plot some points to make sure, not the worst idea you ever had. And there is that function. Okay, last one. So this one, this on the bottom, if it helps you to write it out, it's 3x times x plus 2 times x plus 2. If you'd rather see that. It doesn't really affect things in this problem, so let's just see what happens. Whole, there's none. Vertical asymptote is at x equals -2. Could you write it twice? Yes, of course. But if a vertical asymptote is right on top of each other, it's just going to be one vertical asymptote, so you don't need to write it twice. Your x-intercept is when you set the top equal to 0. So that's going to be 0, 0. Y-intercept is you plug in 0 for all the x's, which would also give you a 0, which makes sense. If your x-intercept is 0, 0, then that's on the y-axis too, right? So it's got to be both your x and your y-intercept. And your horizontal asymptote, The degree of the bottom would be x squared, so the second degree. So since the bottom is a bigger degree, your horizontal asymptote is at y equals 0. Okay, so this one, it's not a line. We're going to have to pick some points, which is fine. So let's graph all of those things. So we had the vertical asymptote at -2. Your x and y intercept at 0, 0. And your horizontal asymptote at y equals 0. Is anybody, and I would be too if I were you, are you freaking out because of that x and y intercept, that point of the origin? Are you like, hey, wait a second, Mrs. Roeder, that's on the asymptote. I thought it couldn't happen. Well, it turns out sometimes it can happen on the horizontal asymptote. Occasionally, like there's a couple on the homework and I believe one on the quiz that will cross the horizontal asymptote. So let's just finish graphing this and see what the points are. So here's the points I want you to pick. So let's pick the following. Make your little table. And again, please put these in your own calculator and don't just copy. Okay, so -10, -6, -3, -1, 3, and 8. So I got all these answers in different formats. It's no big deal. So some of them fractions, some of them decimal. So -10, -15 over 32, -6, -9.8, or 9 over 8, -3, -9, -1, -3, 3, 9 over 25, and 8.24, 1 decimal. It's all right. Those are the ones my class came up with, and it'll be all right. Okay, so let's graph these points. So -10, that's about -1/2, -6, -9 1/8, that's a little bit larger than, or smaller than -1, -3, -9, okay? And then -1, 3, or sorry, -1, -3, my bad. 3, 9/25, and 8.24. So this graph is kind of cool because it does cross the horizontal asymptote, which I told you does happen. But so it crosses it and goes above it, but then it hugs it really close to the line. So it does follow it. It just crosses it once. Okay? So that is kind of cool. It doesn't happen all the time, but it does happen sometimes. Okay, that is it for 8-3 day 2. Please do your homework. Thanks for watching. Have a great rest of your day.